The midpoint formula. So our goal today is to understand the midpoint formula. It's important that we can calculate the midpoint, but we're also going to be applying it in some analytical problems involving perpendicular bisectors and their equations. So let's start off with the easy part, the midpoint formula. So if we have a line segment AB drawn in the coordinate plane, and we wish to find the midpoint, this is the point that is equidistant from A and B. So what you're actually looking at here, when we look at the formula for the midpoint, it's just the average. It's the average x value and the average y value. So you take the x value from A and the x value for B, and then you add them together, divide by 2. That's finding the average of two numbers. Same again for the y values. So this is the formula for the midpoint of a line segment. Easy. Have a go. We have a line segment AB with endpoints A and B. The point M is the midpoint. Find the coordinates of M. Really easy. That's sort of thing. Okay, so we want the midpoint coordinates. So the midpoint M is going to equal -1 plus 7 over 2, comma 5 plus 3 over 2, which is going to be 6 over 2 and 8 over 2. Which is going to be 3 and 4. Make sure you always give it as a coordinate point and that you've got the coordinate brackets on around each one of these. And this is how we do it. That's the midpoint formula. Nothing hard with that one. Let's apply it in some more analytical problems. So to begin with, we're going to look at a bit of vocabulary. We're looking at the word perpendicular and bisector. So in this first diagram, we can see that this vertical line drawn here is a bisector of A and B. For it to be a bisector, it goes through the midpoint of line segment A and B. So any line that passes through the midpoint of a line segment is a bisector. It means it cuts it in half. So this cuts it in half. Let me go over to the last one. So this line drawn up here in this direction, this is a perpendicular line. So this line is drawn perpendicular to the line segment GH. It is not drawn anywhere particular. It can be anywhere along the line segment and it's still perpendicular. This is useful for shortest distance problems, as we saw last class. Shortest distance. So if we had, if we had another coordinate x here, like this one, and we wish to find the shortest distance to line segment GH, it would be along the perpendicular line to the line segment GH. Yes. Question? No? Now, our new one here in the middle is a perpendicular bisector. This requires a 90-degree angle, but it must also go through the midpoint. The perpendicular bisector is useful because remember that it is the average distance. So it's the average distance from D to E, or half the average distance. So it's this distance here is the same as this distance here. These two distances are the same. Now what's special about a perpendicular bisector is this point here will also be equidistant from these two, meaning that we create an isosceles triangle. So this is useful for equidistant style problems. This is useful for equidistant type problems. So here we see a perpendicular bisector of a line segment that is drawn in the diagram. I'll just show you here in a little GeoGebra slide. So if you you notice here that the two lengths, so we have the line segment AB. The line L is the perpendicular bisector through the midpoint. Point C lies on line L. Notice it's equally distant from both sides. And if I move C to any particular point on this line, it's still going to be equally distant. This is the purpose of a perpendicular bisector for us. So the equation of the perpendicular bisector, let's have a go. I'm going to do this one for you as an example. We are asked to find, we have the line segment AB through the coordinates A and B. We wish to find the equation of the perpendicular bisector of the line segment AB. So first, we must find the gradient of line AB. What is the gradient of line AB going to be? So we are going to put in our y values, which would be -1, -5, and then 8 minus -3. This gives us -6 over 11. Can we simplify that? No. This is the gradient of line segment AB. What is the perpendicular gradient to this?
11 over 6.
11 over 6. This is the gradient of the perpendicular. Let's find the midpoint. I'll use a capital M for the midpoint. So we need the midpoint now of line segment AB. That's going to be -3 plus 8 over 2. 5 minus 1 over 2. What have we got? That's 5 over 2.
And 4 over 2.
And this one is going to be 4 over 2. This is 5 over 2, and this is 2. So now we have a point on the perpendicular bisector. So we just sketch the diagram. Here is A, B. We found point M here now, and we wish to find the equation of line L through that midpoint. It goes through this midpoint, has this gradient. So we'll use the point slope form of the line. Y minus 2 is equal to 11 over 6, x minus 5 over 2. This is the equation of line L. In the question, we're asked to present the answer in general form. So if we're asked to present the answer in general form, we have to get rid of all the fractions. I'm going to start by multiplying through by 6. So I'm going to multiply through by 6. This gives me 6y minus 12. Then I'm going to expand the bracket. I get 11x minus 55 over 2. Is my arithmetic correct?
Yeah.
So we need to get rid of that 2 now, because we have to get rid of all the denominators, make it into integer form for this form. So I'm going to multiply through by 2. I get 12y minus 24 is equal to 22x minus 55. Lastly, let's collect together the like terms and move it all onto one side. So we're going to use 22x. If I add 24 to this side, come on, add 24 to this. 31
Yeah.
minus 12y minus 31 equals 0. Just do one last check through to see if I have any common factors that I can divide through by and simplify, but I don't. So typically in the general form we present it like this, where the coefficients are integer values. Okay, that's it for our lecture today, but we've got lots of classwork activities.
What's this?